Welcome to the Improving Edge conference session on unlocking scale and agility with the modern data platform. I'm Rich McCraw. I'm a VP here with Improving out of the Atlanta office. And today we're going to talk about the modern data platform. After the kind of buzzwords over the last decade of big data, machine learning, and AI, organizations have begun to look at what a modern data platform is that can support both our traditional needs as well as these new and emerging technologies. What we're going to do today is we're going to talk about first a very, very brief story of kind of how we got to where we are in the world of data. We're going to talk through what the modern data platform needs to bring to an organization. We're going to talk about why it matters for organizations to begin the transformation to a modern platform. And then we're going to go over a solution for what a modern platform might look like in a very quick overview. There's a lot of content here, so we're going to go very quickly throughout this session. Please feel free to go ahead and put questions in the Q&A or in the chat. We will answer those either as we go or at the end when we're going to reserve a little bit of time for Q&A as well. So since you all joined this session, you probably already believe that data is important. But in case you don't, there's a lot of people out there that'll tell you, right? Every business is becoming a data business. It's becoming a tech-driven business. And the reason for this is not that every business is selling data or mining data, but that data is becoming key for a business to notice how it runs itself, how it can improve, and to look at what solutions it brings to the market. So thinking about how we got here, we want to talk about a brief path of how we got from kind of the beginning of data in IT to where we are today. If we look at the early stages of data in IT, we needed to be able to store data and we needed to be able to retrieve it, right? This seems like a relatively simple problem, but at scale, we came up with the database. And this is what everyone kind of traditionally thinks of as a database does really well. It'll let us store a lot of data in a lot of different ways. We can organize it, we can retrieve it quickly, we can query it. But as uses for that data continued to mature, we started to want to use the data from one system with other systems. We needed to view data across many systems. We needed to look it up in different ways. We needed users to be able to look at the data in ways we hadn't already thought of. So we added more tools to our data platform. We added the data warehouse, we added multidimensional model. But even then, as we reach the last decade, the questions really become, can we store more of it? We have more data than we've ever had before. And we're getting it so quickly, can we process it faster? Can we do things across these vast stores of data that 10 years ago wouldn't have even been possible to store? And that's where data lakes and the world of big data have really come into play and into the modern enterprise. But even with all of those tools, there's always more questions. Well, but can I do that in the cloud rather than in my data center? Can I support multiple platforms? Do I have to be locked in? Well, I need more analytics. I need to enable the business to see more things about the data. What about AI and ML? Right? These emerging technologies are almost fully driven by the amount of data you can use to begin your processing. It starts to get really complicated. And there's not really one answer for what a data platform is. In fact, if we think about a data platform, it's really an ecosystem of tools that's solving a kind of array of problems, from how we acquire data, how we store it, how we retrieve it, how we visualize it, how we do analytics on it, how we as an organization can make use of this data. And because of that, there's not just one problem we have to solve. Instead, there's a bunch of competing problems that always kind of pull on each other in different ways when we look at our data solutions. Do we want to be able to store more kinds of data or more data or report on it more quickly? Each of these needs can be solved with some piece of a data ecosystem, but solving them all at the same time has never really been a possibility. And that's really where the modern data story is coming into play. Tools that let us look at these competing needs and begin to balance them. So let's talk now about the modern data story. Well, if we talk about modern data, by saying modern, we're obviously trying to say there's something new. There's something that's being brought to the table that perhaps our old solutions didn't give us. And any time we look at a new technology, right, we want it to be disruptive in some way. And that's either usually through new capabilities or through efficiencies. From a new capability standpoint, in this case, we want to look at a modern data platform as giving us new ways to leverage data to generate value for the business, because that's the end result that we want. Ways to empower new parts of the business to leverage data that they simply couldn't before, or even better, ways to leverage data that we couldn't even make use of before, and to find value where it was just being lost. From an efficiency, speed, and cost standpoint, that story is a little easier to see. We simply always want things to be better than they were before, higher quality and lower cost, right? Can they be easier, faster, and cheaper? And so we're going to talk about these in the realm of the modern data platform. But as we do that, we also have to think about what capabilities the modern platforms having to bring to the table that let us do things we couldn't do before. And there's a few concepts we need to talk through to make that make sense and why the modern data story was a necessary evolution in IT. And the first is structured versus unstructured data. You may have not referred to it this way, but everyone's really probably familiar with the idea of structured data. Structured data is data that I know about. I know what's in it. I know how it's formatted. I know what it's supposed to look like. Right? This could be a spreadsheet. This could be a traditional database. This is something where the structure is relatively well defined and I know how to query it. And this is kind of the world that data solutions were tied to for decades. But then there's always been this idea of unstructured data out there. And that's just the raw data. That's the data however it can be collected, wherever I can get it across any number of points that are collecting data. Some of that might seem useful, some of it may not, right? It could be temperature readings of 10,000 refrigerated trucks on the road, right? That may not seem to be something we need immediately, but the data's there. So it's raw data. It can be stored in any number of formats, and you can usually search it. We've developed some pretty good tools to allow textual search across unstructured data, but it's not really modeled and queryable and useful for analytics in an easy way. And that's where the modern data story brings in the idea of semi-structured data. Semi-structured data is loosely organized data that can still be stored in various formats, where we don't have to throw away the data that we don't know if we want to make use of yet, or the pieces where we don't know whether or not we even understand why we use it yet. We can define the structure for the pieces that we do want to use, define that with metadata, and then the platforms provide both search and traditional query on top of this data. So it really can be the best of both worlds. It gives us the ability to query something like structured data, but to keep associated with it all of the other unstructured data that we may find we want to come to use later. One of the reasons this is so important to the modern data story is not just because we've developed better tools or that storage has gotten cheaper. It's because we simply have more of it now than we ever did, right? If you look at 2010, there was structured data and unstructured data in about equivalent amounts. But if you look in the last decade, unstructured data has grown at a much, much faster velocity than structured data. And so by simply using traditional data tools, we have fewer. Apologies, I believe my PowerPoint showed you the presenter. You'll see that in the last decade, we simply need more unstructured data, or we're losing the vast majority of the information coming into our organizations. We also have new kinds of users that need to use this data, right? 10 years ago, Data science was absolutely the buzzword. And if we looked forward in the industry, we all believed that data science would be leading the charge, and the data scientist would kind of be the vanguard of that in organizations. But as data has become more important, as we have more of it, there simply aren't enough data scientists to fill those roles. And so what you've seen is organizations, rather than focusing on hiring data scientists, organizations have begun to focus on hiring data engineers that can empower the analysts they already have. These are systems to allow the engineers that can access the data to give the employees that already have the domain knowledge the ability to do the analytics that's needed across a modern data platform. And then the final kind of sea change that the modern data platform brings is the idea of bringing compute to the data. And if we think back to kind of a traditional database, you've got a server, and that server had a database on it. And if you wanted it to be failure tolerant, you might be lucky and have 2 servers. And if those weren't speedy enough, or you had a really big problem, you might make them bigger. But that was really all you could do, right? When I needed something to be faster, I either had to write it more smartly, or I just had to buy a bigger boat. In the modern data ecosystem, we look at a variety of storage options that can let us use this structured, semi-structured, unstructured data. And we couple that by bringing compute workers to the process. And if we need more capacity, if we need the ability to scale for more processing, all we have to do is bring more workers to the data. And as long as our data backbone, those data lakes, those blob storage, can handle the load, the workers only have to focus on how they compute across that distributed data. This is really important for how we achieve cloud scale on data.
Hey, Rich, your slide's getting a little bit cut off on the right side. I think when it flipped over, it is kind of cutting off a little bit of your slides now.
Thank you, Justin. We'll attempt to fix that. Did that solve the technical issue?
I'm not seeing a screen share now.
Did that solve the technical issue?
Yep, there we go.
Thank you very much, Justin. So when we look at the modern data ecosystem, it's not just new, it's these traditional structured data platforms, the newer big data or semi-structured platforms, the tools and interoperable standards that let us use them together, and that idea of bringing compute to the data in a way we can get to cloud scale that are really going to enable us to move forward. So what does that look like? This is a great overview of the data and AI landscape that was put together by a market analysis firm in 2020. And if you can even read all of the logos on it, you're probably doing better than I am, right? This is a vast, vast industry with tons of solutions. And there's really no way that anyone can understand what all of the solutions in play are and what the nuances between each of the solutions are. So how do we pick, right? That slide certainly puts us past the point of, oh, there's some great new concepts we want to leverage, to there's simply so many choices out there. How do I start? And so the answer with that is where I want to really pivot the next part of this conversation. And that is, we want to start with the capabilities that we want to enable in the business. That's how we want to pick parts of this platform. It's not something where there's one solution we're going to pick off the shelf and say that is now our modern data story. But we need to think about and look at what capabilities we think will bring us either those new capabilities in a disruptive manner, or will bring us some efficiencies over what we do today. We're going to do that by picking out building blocks. And we want to start with strong, flexible building blocks that build a foundation for our data story. And one of the reasons for that, and one of the great things about the modern data platform, is because these pieces work so well together, we can be wrong, and you're going to be wrong. No one can look at that slide of hundreds of choices and perfectly pick the right stack for any problem. Instead, because many of the tools on there do similar things with just slight nuances that might be different for a different business, a different problem set, we may not pick the right tools the first time. But if we pick the right capabilities and the right building blocks, it becomes a lot easier to adjust and bring the right additional tools as we move forward, as opposed to kind of the old monolithic data structures and data platforms that used to have to be a centerpiece that couldn't get moved and couldn't change for a decade at a time without causing all kinds of cascading changes through an organization. So what I want to do now is talk through 4 or 5 concepts that really make up those core building blocks. That if we are building a modern data platform, these are the pieces we want to think about bringing to the table first, and whether or not they fit our vision for what the modern data platform needs to mean in our organization. And the first, and probably seemingly most nuanced, is the idea of ETL versus ELT. Right? ETL was the buzzword for 20 years and how we loaded data, how we brought data in and put it in a data warehouse. And ELT may seem like just a poor typo, right? Or a very, very small change. But in reality, it's a fundamental change in the way we think about what we're doing with our data and when we make decisions about it. So to go back to kind of an example of what these are, in an ETL process, we got raw data in, we transformed it, massaged it in the form we wanted to use it, and then we stored it. And that worked great if you only wanted shredded carrots. But if you wanted anything else, that needed a new process, and we needed to get the data again because we'd already turned it in to shredded carrots before we stored it. ELT takes a different approach and says, let's take the data in as close to the form we get it as possible. We may do a few things with it to kind of normalize it and make sure that we understand what's in the data, but let's store it and then determine how we want to transform it or structure it for downstream systems. And that way, if we need shredded carrots, we can still do that, but we also can fill other needs of the data that we may not have thought of when we first started building or getting this data feed or data system. Some people have complained this slide is not technical enough. So there's a technical version for it if you want a screenshot. But the idea is the same. Do I take the data and transform it before I store it? Or do I store it, have a bunch of modern systems that can use it in that format, and then do further transformations only as I need to feed other specific needs or systems downstream? Another core piece of a lot of modern data platforms is the idea of streaming data. And while there's a number of solutions out here for that, Kafka is probably one of the most common you might have heard of. And the idea of a streaming data platform really sometimes doesn't seem like data at all, right? It may actually take you back to the idea of a message bus or messaging systems. But it really solves problems in both messaging and data at the same time. And a streaming data system is used when I have continuous movement of data. I might have multiple inputs and multiple destinations or consumers of this data. And I need a way that at scale across multiple nodes, I can durably and reliably process this data, move it to where it's supposed to go, make it available to the other systems that are interested in it, but also give views of aggregate or most recent versions of the data. So for instance, this could be, I have 10,000 cash registers spread across 1,000 stores across the Southeast. And I'm using a streaming data platform to bring the transactions in to my central system. At that point, I may be using the streaming platform both to route transactions for use in my central booking system and my cash flow system, but also I can use that platform to report on the aggregates of the data and see in real time as the counts and totals, the types of transactions move throughout the day. I also could use this against quickly changing records to always give systems a view for what is the most recent version of a record or a set of records that are in process and being worked on in the organization. Some other great examples where streaming data gets used a lot today is in log aggregation and analytics. And that's kind of the key thing you're going to hear about streaming. It's data in flight, it's moving, but we're also trying to do aggregation and analytics while it passes through the system. There's also a number of processing frameworks which take advantage of that idea of bringing compute to the data. And they generally break down into two different forms of processing frameworks we want to think about. There is the data parallel frameworks, Apache Spark, Hadoop. These are traditionally what we think of as big data. They're batch processing system, and each of the different workers might be working on a subset of the data or even its own copy of the whole set of data, depending on how much data we're talking about here. This is where I may have one complicated question I want to ask across a large set of data, and I want many different workers helping process that one question to come up with the different pieces, to come up with a result in a way we just couldn't have done in traditional database technologies. So this is really the one complex question, lots of workers. The other side of this, and very similar until you really get to the technical implementations, are task parallel processing frameworks. And these are what we call micro batch processing. They're working on individual records or very small sets of records at a time. Some of the differences between them and the data parallel processing frameworks is they are very low latency. These really are as close to real time as you can get. And the best way to think of these is one task, but many workers doing it lots of different times. A good example could be attendees flowing in to a sporting event or a concert. Right? I've got lots of lines and lots of ticket takers, and each ticket taker knows what to do to scan and get the next person into the system. With a task parallel process, we're using those workers to scale out and handle lots of little tasks millions and millions of times, rather than in a data parallel world, we're asking one big question across millions or billions of records. And then finally, kind of the most core technology that underpins this, and probably the biggest building block we need, is the data lake. And the data lake is one of those things like business intelligence bit, where it's one name, but it really means a lot of different things depending on who you ask. So for our purposes, I'm going to look at how Microsoft defines it. And Microsoft defines their data lake as a storage tier with an analytics tier on top of it that brings those processing frameworks we just talked about. In fact, you'll see here they've got Hadoop, they have Spark, they've got Storm listed as the particular things that that analytics framework is enabling to work across that data. The thing is, this is not a uniquely Microsoft view of the world. If I was to ask Amazon, I get a different diagram, but the idea is really the same. The data lake is those core technologies and components that give me my storage tier and the ability to bring the compute to that storage. And that storage tier is kind of by definition going to be something that can handle both structured and unstructured to semi-structured data. That analytics tier is going to support a large number of processing frameworks. And this is where we really get the ability to begin to mix and match tools. Because almost every tool we talk about in a modern data platform is going to support data lakes. And the great news is those are so widely similar that even though there may be differences in how they're stored or how they perform or how they're costed, most of the tools will work with almost all of the modern data lakes you're going to run into. So this is certainly a very core component to any modern data ecosystem we want to look at. So those are a lot of kind of technical pieces. if I want them and I know I need them in my organization, why does it matter? Why does it matter if I adopt these things? Why does it matter other than it's a cool new shiny toy for my developers and for my infrastructure teams to play with? And the answer is going back to that idea of disruption. It's going to bring us those new capabilities, new ways to leverage data, to enable new users to get at the data, to empower new parts of the business to use the data that couldn't before. But most importantly, to leverage data that we simply didn't have a way to leverage or couldn't leverage economically before. That's where the semi-structured data comes into play. And that's where scaling out our compute workers really let us do things with data now that we couldn't do before the modern data platform. And then we always say we want better, higher, and lower costs, right? So how are we going to get there? And that's what I want to break down here for a minute, since we spent some time on those new capabilities already. So first off, if we look at why people are investing, why are people moving to modern data platforms? What's actually causing adoption? This is a survey that was done by Amazon a couple of years ago, and you'll see that the answers really cross the spectrum of new capabilities and cost improvements, right? About 43% wanted operational efficiencies, right? They wanted to maintain data that's from different silos, different systems, lower transaction costs, replace mainframes, replace traditional data warehouses, right? And beneath this, there's really a mix of new capabilities we didn't have, better ways to implement existing capabilities, and then cost savings. And those cost savings can also come from the idea that as we move to the cloud, we can leverage cost elasticity. We can pay for utilization, not capacity. If you think back to data centers, right? If you wanted a large amount of data processing capacity, you had to buy that capacity, and then you had it, right? And even if you were only using all of that capacity a few times a month, a quarter, or a year, you had to have that amount of capacity if you were going to ask that size of questions of your data. Even as we began to move to the cloud, you still saw that you had to buy the size data platform or the size data service that would let us query the things we need. But with the modern data platform and the idea of just scaling up the number of workers across a consistent storage tier, you find that a lot of these solutions now can be driven almost purely by how you utilize them. This graph specifically is an example of Snowflake's pricing, one of the modern data cloud platforms we'll talk more about in a minute. And the idea here was a traditional data warehouse has a flat cost that you had to pay to keep it up and running, even in the cloud. And they've even put a nice little bump in here to say, I may scale that up towards the end of the month when I know I'm doing more processing. But it was still committed volume just so I could handle the bursts where I had one really large or hard query. The way Snowflake works is it's going to look in increments of down to 1 or 5 minutes and say, how many workers do we need? Let's use those. And when they're going idle, we shut them down. And so that means when you're not doing anything, you're only paying for storage, which if anything we know about the last few decades, storage has become cheaper and cheaper, right? But what's also nice is there's no need for kind of the pre-decision of, well, here's when my spike's going to happen and here's how big it needs to be. Because the ability to simply add more workers rather than make your existing workers larger, let these modern platforms dynamically scale up and down as the workloads demand it. And that keeps you as close to the amount of utilization, the amount of computing power you need for the questions you're asking. So it's a great way to get your costs as close to your needs as you can get them. Doesn't mean this is free though, right? Cloud companies are not dumb, right? And they don't want to leave a lot of money on the table. So studies show that over a 10-year time span, moving to software as a service or cloud services doesn't really change the total investment and technology of a company. But what it does is it spreads it out and it ties it much closer to what your company's doing and what's strategic or what's operational today, rather than making you make a bet to build a system that you think can handle things that are coming for the next 3 to 5 years. In this case, I build it and I'm paying as I use it. And if my business changes or if my business explodes, right, that utilization can go up and down and the costs and investments can change with it. So this isn't the idea that I'm taking what I had before and now I can do it for free. It's I'm taking what I did before and now I can do it where I'm investing specifically at the times that I believe it adds values to the business, and I'm increasing that investment, usually in lockstep with that value, either increasing or decreasing. So if those are the reasons we want a modern data platform, and we've talked about some of the things that make up a modern data platform, we still have that enormous slide of hundreds and hundreds of products. And so the question is, what is a modern data platform? And so what I want to do now is show you really quickly a few ideas of what a modern data platform might look like for your organization. So the first one here is the reference architecture for the Azure modern data platform. This is Microsoft's best practice of what does their full modern suite look like. And there may be a lot of icons on here, and it still looks like a lot of prominence. But if we actually look at each one, you're going to find they all tie back to those same capabilities and those same new features that we talked about before, right? There's a data lake at the center. Databricks and cognitive services and streaming analytics are different ways to bring compute to that data. Synapse Analytics is a way to provide, again, ways to bring those workers to that data that's stored in that data lake. Right? These are all pieces of that same puzzle, right? Power BI Premium, other applications that can connect to Cosmos DB, those help enable those business users to do analytics themselves across the data that the data engineers have prepared. Data Factory can be part of an ELT instead of an ETL approach. It's the same concepts, just brought out in kind of a variety of pick which pieces you need. And that's very important because very rarely is the first implementation of a modern data platform going to include everything that's seen on this chart. In fact, working with the client recently, this is what we put together as their initial steps on a modern data platform. They still needed some of the same new capabilities and new services that we talk about as part of the modern platform. But there are other pieces they didn't need. So we're able to simplify it down to what are the tools they need to handle what pieces of capability their business needs to solve problems. And in fact, even this was more complicated than they needed initially, as we were able to do a first pass, which even took subsets of tools out of those options and found a very streamlined pass through that let them do some immediate data projects and get some immediate value out to the business while starting to put into place building blocks that tie in to that larger view and can grow over time to be that more full-featured data platform. And if that still seems a little too, well, we have to pick and choose, and I need someone to help walk me through this, you also have some platforms out there that are trying to wrap this all together for you and give you more cohesive solutions. Snowflake is a great example of this. Their tagline is they are a data architecture built for the cloud. And what they've done is they've created a storage tier and a compute tier that they keep completely separate. So you give them data and they store it, and then you pay to bring compute to it as you need it, right? That makes it elastic. That gives you the utilization-based billing, supports multiple cloud platforms, right? Because at the core, we have these ideas of blob storage and data lakes across all of the major services. It can integrate in both reading from and writing to almost all popular data lakes, but it's all delivered as a service, right? As a turnkey. I turn it on, it's auto-optimized, uh, auto-scaling cloud data platform that utilizes behind the scenes technology different than just our traditional old databases. But even then, it's not quite as simple as just saying, great, there's a SKU, I can buy that, and my company's now a modern data company. Even with Snowflake, there's got to be an ecosystem of tools that you're also bringing to the table. Now, the great thing is they integrate with and have these tools supported. This is a graphic stolen directly from their support pages. But you'll see even then, to complete the story, to bring in security and governance, to bring in ELT versus ETL, to bring in the empowering and democratization of the business analyst to run the types of analysis they need on the data, we're bringing in additional tools to the framework. But the great thing about it is, once again, what if I pick the wrong tool? Well, I'm not having to replace the core. Snowflake remains the same. The way I'm bringing compute to the data remains the same. Instead, if I determine I don't like SAS, I can use Alteryx or Databricks. And I can make those changes without being disruptive to the actual foundations of what my data team has built. So in review, we've gone very quickly here in kind of a whirlwind 40 minutes through the modern data platform. And if we think back to what we talked about, the modern data ecosystem is really traditional data. Right? That's not going to go away. Structured data and all of the types of database systems we've used for that over the years. The addition of big data, semi-structured data, and cloud scale storage tools. More and more tooling and interoperable standards to let business users bring the tools that help empower them to the data that the data engineers can build. And that idea of bringing compute to the data to keep my cost elastic, to use the right type of platform for a problem, keep it efficient and low cost. And that is what we call the modern data ecosystem. So throughout this, Q&A has been open. We're going to spend a few minutes here answering any questions that any of the attendees have. I thank you very much for coming and spending 45 minutes with me talking through the modern data ecosystem.
See, I'm not seeing any questions in right now, but if you guys have questions out in the audience and you want to ask Rich, definitely throw it in the Q&A, and we've got some time here to answer some more questions.
Yeah, it looks like everything in the chat got handled. Also, while anyone's writing those questions, I do want to thank some other improvers who helped with putting together the content of this presentation and kind of bringing some of their perspectives of these tools. Chadwick Smith, Andrew Pierce, Dave Rains, and Scott Michael. I also want to remind everyone that the EDGE conference is going on for the rest of this week. This is just the first day. We have 3 different talks every day, and you can register free for any of the sessions at theimprovingedge.com.
And this presentation and all of the presentations will be available on Improving's YouTube channel by Monday of next week, and all the slides will be there as well, if you want to check that out later.
All right, thanks everyone for attending. Please feel free, if you have any questions that come up after this, if you would like a deeper dive, please feel free to reach out to me, to Justin, to anyone else at Improving, and we'll be happy to talk you through more details.
Let's see one question.
Yep, and last minute here, we got a question. The question is, many vendors provide storage services, but a lot of companies want to bring them in-house. What would you say are some of the biggest factors to consider? I think the uses of that storage become really important. If I'm talking about storage for a traditional database, if I'm talking about storage for archiving, for purely transactional systems, which might also be housed on site, certainly that can make a lot of sense. When I start talking about scaling storage solutions out for cloud scale data solutions, the requirements of that are dramatically different than what we used to do with SANs and network centralized storage. So you really need to be looking at bringing in a solution that mimics or implements some of these cloud solutions, some of these HDFS, big data, replicated and distributed storage solutions, if you want to be able to reliably bring this kind of compute to the data and scale it out story to your data. It is not impossible to do in your own data center. Certainly a lot of the major platform providers like Azure and AWS have ways for you to take a lot of their technologies and bring them in-house. There's a lot you can do in an infrastructure code manner to really stand this up in a kind of automated and manageable way using containerization and lots of either open source or again, on-premise versions of cloud solutions. But it is a different problem than kind of the traditional in-house data center kind of storage solutions brought to the table. And so I would say the biggest thing to consider is, what am I looking to do? Am I trying to store backups? Am I trying to have relatively static systems that are used for OLTP, where only small volumes of the data are changing, or I'm doing analytics on a piece of data at a time? Or is this something where I really need kind of the scale, the redundancy, and the ability for that same data to serve 20, 30, 40 different worker processes at the same time, that really those more modern platform cloud solutions do natively, or at least bring one of those similar technologies in-house. The other question that's come in is, do you see cases where the old model of on-premises data storage is less expensive? And the answer is sometimes, but only if you look at it kind of sideways. And that seems like a silly answer, but there is absolute truth to saying that if I take a on-premise database that I have running on a SAN I have today, and I move it to the cloud like for like in sizing, I'm probably going to see a degradation in performance. So I'm probably then going to scale it larger in the cloud. And at that point, I'm probably paying more than I was in my data set. And so kind of on the face of it, right, that is a case where by moving off of premise, I've not saved money. I'm actually probably spending more and running into some different constraints that I didn't even have before. But the real problem there is, as you move to the cloud, it's not a lift. It's not a, let's do the same things we used to do. Let's run SQL Server, let's run Oracle, let's run MySQL, or whatever it was, the same way we ran it and optimized it and used it in our data center. We have to pivot both the tools we're using, but also how we're leveraging those tools as we move them to the cloud. And if we do that, we can become a lot more efficient with both what we're paying for storage, but also what we're paying for compute. And that's really where you get the cost scale of the cloud, right? If I size the cloud and I move things up and I pre-reserve the exact same amount of capacity that I had in my data center, I'm probably not really changing the paradigm in any disruptive way. And so those are cases where you may only see cost savings if you happen to have some more favorable licensing, or you see more favoring overhead and IT operations expenses. But to really change the way my data processes and my data storage cost me money, I've got to change the way I use them as I move them to the cloud to really leverage some of the things we talked about in this platform. And when that's done, it's almost always going to get less expensive because it's almost impossible that you're utilizing what you have on premise 100% at all the time and not feeling constraints on one end or the other. And so kind of by the nature of changing that, you're going to change the way things cost, and you're going to have a lot more flexibility to do it in the way that is the most efficient, makes the most sense for you. Another question's come in, couldn't we realize savings if we look at reusing technologies in-house too? Absolutely, right? Reusing technologies in-house is is a great way to save data, and always adding new technologies to the stack is a good way to continue to spend a lot of money and not really see dramatic change, because you can only make dramatic change so fast and so often in an organization. The idea with the modern data platform is we're able to look at data in a unique enough way, in a different enough way from the traditional databases that it really enables us to do some things we didn't do before. And the cloud can be part of that, but it doesn't have to be the whole story. Almost all of these technologies can be run in your own data center on containers, right? These are things you can bring in-house, and there's also a lot of different variants out there, because for each of these, you could build your own version, right? You could build your own set of workflow processing frameworks, set it up on your own containerization service, and let it run. The chances are, though, the efficiency, the speed, and the continual improvements you get from bringing in some of these main platforms will way outstrip those costs very, very quickly. But at the idea that it has to be on the cloud or has to be in-house, you can get there either way. And there certainly are, some places where data must stay on premise or must stay in the walls. And those are places where private cloud or using the open source containerization options really can help you move this ball forward.
And then you've got one more question in the chat.
I will do my best to find it. There we go. How can digital platform technology best support collaboration? That is a great question. And that is a question that I think written broad could be its own session and set of topics. If I want to look at it through the lens of modern data, some of the ways that this can be supported is, I think that the ELT change from ETL and the interoperability of these data platforms with multiple analysis frameworks on top of them really are one of the things that allow a lot more collaboration on data a lot earlier in the process. And the reason for that is if you think back kind of to the old mindset, right? I had to have data engineers, I had to have data stewards kind of define what my domain was, figure out what data the business was likely going to need. Hopefully they talked to the business, but then again, even the business might not have known what data was available or how they might want to use it. Build models, transform and load the data into those models, and then hopefully at that point, someone built some reports or gave the business some set of tools that let them see what they wanted in that data. And after doing this for 20 years, I don't think I've ever seen it where the very first pass of what someone thought the business wanted, or even what the business thought they wanted, was in the end what was needed. And so that became very costly. You had to go back, redefine how things were going to be stored, build a new, more robust model, figure out how to reload all the data again. Hopefully you hadn't lost all the historical data or lost an important piece of data that was overlooked. Load that in if you were able to get it and start the process over again. And the feedback cycle there, depending on the size of your organization, could have been weeks to months. And when the feedback cycle is that long, there wasn't a lot of collaboration, right, between the business or between different parts of the business and the data team. What's great about these tools is with ELT, I store the data, And I'm able to put these worker processes on top that allow the data analysts to get the data with tools they're comfortable with, right? With Excel, with different Python workbooks, with tools like Alteryx, where they can really look and see what's in the data and determine what's useful to them in a way that gives much more direct feedback, but also can get feedback from multiple stakeholders in a much quicker way to allow the data engineers to continue to improve that process and add new things out there. So, I think the answer is you still probably can't have two people working on one data load. But what you can do is make a lot fewer guesses in the data load, not hope you got it right, but instead get the data in there, enable everyone to get in it, and then find out what are the real requirements, what are the real pieces of data that can drive value, and then the focus and effort can be spent on those, which may then be modeled and placed through more traditional tools because we want them to be in a robust model that's now going to be self-service across the organization. Or it could be that the data analysts have found a trove of data that no one ever thought that they would want to put out for self-service, but absolutely enables some AI or ML opportunities that no one even thought the data was there for to drive. And so the sooner we can get the business to see the data and find what's valuable to them, the better job we can do as data engineers and practitioners to then enable them and enable the business to leverage that data.
I think that's all the questions we have. Appreciate you, Rich.
Thanks everyone so much. Please remember, register for the other sessions. We've got 12 more sessions here over the next 4 days. There's some great speakers and topics lined up. It is free for all. Please register, and thank you for joining us today.